In section 7.3, we'll be discussing how to use your calculator for AP Calculus problems. So there are 5 main calculator skills you're going to need to have. You're going to have to graph in an appropriate window, solve an equation using X-Intercepts, solve an equation using intersection points, calculate a derivative at a specific value, and calculate a definite integral over a specific interval. So in this lesson, we're not going to be learning any new calculus skills. It is only learning how to do those calculus skills we already know on a graphing calculator. There are 2 very important things to remember. You always want to be in Radian mode. So the calculator I have here is a TI-84 Plus. I hit the mode button here. I can see it says Radian. There, I want to be on Radian and not on degree. Sorry, I'm one down. Radian, not degree. So I want to make sure that's highlighted. Your button might be in a different place, but just make sure you're on Radian. It might say rad, R-A-D. The other thing is I always want to give at least 3 decimal place accuracy, either rounded or truncated. That just means cut off, unless it tells me otherwise. You want to make sure, again, on your calculator, on your mode, you might have something about like floating decimal places. You don't want to cut it off at 3. You want to be able to see past 3 decimal places. So I have mine on float. The numbers after that are like if you always want it to round to 3 decimal places. We're not actually going to use that. We want it to float. All right, so in number 1, we have a function f. It is x squared minus 2 sine of x squared minus 5. We're going to be using that for this whole problem, A, B, and C. And so whenever you have, like especially on a free response question, a function at the beginning, your first stop would be to put this in your y equals. So I'm going to call this y1. So I have x squared minus 2 sine of x squared minus 5. And it's also good practice for you to write down what you save this as. So this I'm saving as y1, so I remember that. This is helpful if you have more than one function in your problem. So in part A, we want to write the equation of the line tangent to the graph of f when x equals -2. So we know that we will need a point and a slope to find that out. So f of -2 is our point. F prime of -2 is our slope. Those are the 2 things I need to find. I can find both of those things on my calculator. If I've called this y1, that's acting like my f here. So if I want to find f of -2, so I go back to my home screen. I did that a little quick. So if I'm on anything else like y equals or my graph, I hit second and then mode to quit. Notice it says quit above there. That will take me back to the home screen. You always want to do calculations on this screen, not on any other screen. So if I want to do f of -2, I'm going to do y1 of -2. So to find y1, you're going to hit variables. It says bars. Then go right one to y variables. Hit enter or number 1 for the function, and then I can choose y1. And so just like I would write f of -2, I'm going to write y1 of -2. Make sure for the negative you're using this negative symbol down below, not the minus sign. It will give you an error if you use the minus sign. So make sure you're using a negative. End my parentheses, I get that answer. So I see I have 5.6829. So if we're doing 3 decimal places, I could either cut it off right after the 2 and say 5.682, that will be okay. Or because the 4th digit is more than 5, I can round it up to 5.683. Either one is going to work for you. I'm going to go ahead and just say 5.683. Now there is a shortcut there. So this will only work if you have an updated TI-84. To get to the y1, if I hit alpha and then trace, it will give me all of my different functions. So I can click y1 and do the same thing, -2 there. So this is most often how I'm going to do it on my calculator. But just know that if your calculator does not do that, you can go to the variables and then y variables and then your function. Now the other thing we needed to find was f prime of -2. So I'm going to need to find the derivative of f at -2. The derivative button is if you hit math, and then I see number 8, it says n deriv, that means numerical derivative. So I'm just going to hit math, and then the number 8 will take me to the derivative. Now notice this looks like our normal Leibniz notation that we've used before. So I'm taking the derivative with respect to x, that was my variable. My function here is y1, so I'm going to either hit the variables button or I can do the shortcut alpha trace y1, and then this is at x equals blank. This x will automatically fill in when you fill in your first x ddx. This is where I want to take the derivative at, so I want to evaluate that at -2. And so I get 0.3224. So I do have to write that as just 0.322. Now I do want to show you how to do that same thing if you have an older TI calculator. When you do a derivative, it's going to come up looking like this. I'll show you how to do that. So I do math 8, same as before, but what you're going to have to do is type in your y1, so variables, y variables, number 1 for my function, y1, and then I do comma x, that's the variable we're taking the derivative with respect to, so that's the same as doing d over dx, and then comma whatever number I want to evaluate it at, -2. And then notice I get the same answer, it just doesn't look like our math type here. Now I still need to go and write my tangent line equation, y minus 5.683, my y value equals my slope 0.322 times x plus 2 minus -2, and that will be my answer. Again, I don't have to write down everything I did in the calculator. Notice I did not write it out like how I typed it in the calculator. I just connected it back to my function. In part B, it says the graph of f crosses the x-axis at one point in the interval from -3 to 0, and it asks me to determine the slope of the tangent line to f at this point. So the first thing I need to do is figure out this point where it crosses the x-axis, and then I need to determine the slope. So let's find the x-intercept first. So I'm going to go back to my calculator, and what I'm going to need to do is graph this. I want to point out, though, that it gave me this specific interval, -3 to 0. So whenever you're getting ready to graph a function, you need to decide, do you need to show it in a certain window? So I'm going to hit Window. Now, right now, my window just says 0 to 10. This is from a previous problem. I need my x-min to be -3, my x-max to be 0. X scale is where your tick marks will be. 1 is fine in this problem. We're maybe not too sure what the y values are for this function, so if you're not sure, I always start with -10 to 10. It's a good place to start. Y scale is 1. You pretty much shouldn't have to worry about the x-res, delta x, etc. I'm going to go ahead and click Graph. And so I see my graph here. It has one x-intercept, which is what it told me. F crosses the x-axis at one point. So I have this one x-intercept right there. And I notice it's not at like a whole number like it would be maybe if if the graph had been given to me. So I'm going to have to use my calculator to find that. So I'm going to hit Second Trace, which is the Calc menu. Most often when you're looking at the graph, this is the menu you're going to use for your different options. So notice it has a lot of different options here. We're trying to find the x-intercept, which means we're looking for the 0, number 2. At the bottom, it's going to ask you, it's going to prompt you for different things. So in this case, it's asking me for a left bound. So as long as this cursor, I call it Mr. Blinky, as long as Mr. Blinky is to the left of my 0, then I can go ahead and hit enter. You can also type a number if you would like. Now it's asking me for a right bound. So I need to move my Mr. Blinky to the right of the 0. So I can use these buttons here just to move it to the right. And it doesn't really matter how far right you go, you just want to make sure you're around this 1, 0, and there aren't any extra zeros in between. So essentially one of your points should be above the x-axis, one should be below. It will ask you for a guess, you don't need to worry about that, just hit enter. And it tells me that I have 1.099621, so this answer down here. So I'm going to write that my x-intercept, so this is f equals 0 at x equals negative 1.09962, and I'm just going to put ... Now, what's going to be helpful to us, we need to determine the slope at this point. I don't want to have to type that whole number in every time, and so what I can do is store that value. So as soon as I find my 0 here, make sure this is still on your screen. You're going to hit second mode, which is the quit. I'm going to go back to my home screen. I wanted to store that X value. So I'm going to hit X, my variable button, store, STO, it's right above your on button. And then you can choose any letter you want. I'm just going to use A, so that's alpha math. So you'll see there's some little letters up above in green on my calculator. So I'm going to hit X and then save it as A. Now whenever I type in the letter A, it is stored as that number. That way I don't have to retype this whole thing. It is important for me at this point to not cut this off and just say negative 1.099. If I plug that into my derivative, I might end up with the wrong answer. So I want to use that whole number, but not have to retype the whole thing. So even on the AP test, I can say, use an arrow and say that's A now, so they know that I've stored that as A. The second thing I need to do is find f prime of A, the slope at that point. And so I'm going to go back to my calculator. I'm on the calculator screen, the home screen, not on the graph. I'm going to do the derivative at that value. So math 8, again, is your derivative with respect to x of y1. So that's alpha trace, or it's the variables button. And then I want to evaluate it at x equals a. If I didn't store that as a, I would have had to type in the whole number negative 1.099620591 in order to get the most accurate answer. And then I hit enter, and then I can type that answer, negative 5.703. You could also have it as negative 5.702 if you truncate it. In part C, it tells us that L is the line tangent to the graph of f at x equals 2.5. We want to find the values of x where the line tangent to the graph of f is parallel to L. And so that means the slope of f is the same as the slope of L. Parallel lines have the same slope. In other words, we want to know where is f prime equal to the slope of L. But the slope of L, since it was a tangent line, is f prime of 2.5. So the first thing we need to do is find the slope of L, which is f prime of 2.5. We'll still be using, it's essentially what we just did on our calculator. We're going to do math 8 derivative with respect to x of y1 at x equals 2.5. That will give me my slope of L. So I need to write on my paper f prime of 2.5 is 1.846 ... Now, just like we did before, we're going to store this. We can store it as whatever letter we want. So I'm just going to store this as B, so we're not confused about the A from before. And so if I'm going to store this as B, I don't need to use X like I did up here because I see the number right here. So all I need to hit is store. And notice it says answer. It's taking my previous answer. I'm going to store it as the letter B. That way I just have to type the letter B. I do not need to retype this whole number. Now what we need to solve is when is f prime equal to this number B? And so when we want to solve an equation that has something on both sides, then I need to use the intersection tool on my graphing calculator. So right now when I look at my graph, this function y1 is my f. I need to graph f prime. So what I want to do, I can put the derivative in my graph here. So I'm going to do math 8, derivative with respect to x of y1, just like we did on our home screen. The difference is I want the derivative at every point, not at a specific point. So I can put x here. That will give me the derivative function, f prime of x. The other point I want is b. I want to see where those two intersect each other. Now, I don't want to have too many graphs going on. You can see I have a preview here of these graphs. It's going to be a lot going on. I really just want to focus on f prime and b, which in this case is y2 and y3. So I'm going to turn y1 off. So to do that, I put my cursor over the equal sign where there's, it's blinking there right now, it's bold. If I hit enter, you'll notice it's not bold anymore. That's turning it off. I still need to have that equation written there because I'm taking the derivative of it for y2, but I don't want to actually look at the graph. Now before I go to graph, again, I want to focus on the interval -1 to 3. So I'm going to change my x values to -1 to 3. We might need to change our y values, but we just need to make sure we're really seeing this y value 1.846. Let's go ahead and graph that. Now, when it's graphing your derivative, it's going to take a little bit more time. Alternatively, you could have actually taken this derivative by hand, but it's easy to make a mistake, which is why I prefer to just use the calculator operation. So let that sketch out. Now it's going to sketch the line y equals b, and we need to find these intersection points. So essentially, when is my derivative equal to this certain value? So I'm going to hit second, trace. So again, I'm going to my calculate menu. In this case, I want to find intersection points. So number 5, it's asking me for first curve. I can tell it's on y2 right now. It will tell me at the top. I also see it on that graph. Hit enter. Notice then Mr. Blinky jumped to the other curve. It's on y3 now. It's asking me for my second curve. I can just hit enter. For guess, just hit enter again. And it did give me that point, x equals 0.682. I don't need to use this value for anything else, so I can go ahead and round it. I don't want to round if if I'm going to use that number anywhere else. I only want to round at the end, but this is the answer I was looking for. Now, it does say find all values of x where f prime is equal to this number, 1.846. So I notice I have other intersection points. I need to find those as well. So I still do the same process. Second, trace. I'm going to do calc, which is calc, and then do intersect number 5. What's going to be different though is if I want to find this intersection point over here, I need to move Mr. Blinky closer to that intersection point. It's going to find the intersection point that's closest to your cursor. So I want to find an intersection point over on this side. Hit enter. It's asking me for my second curve, hit enter again, and hit enter. So I get 1.921. Now let's check. I see a third intersection point, same process. Second, trace, number 5 for intersect. And so I don't have to be right on top of that point, but I just need to be close to the intersection point, closer to that one than the others. Hit enter, and hit enter again. And it gives me that intersection point of x equals 2.5. That might seem familiar. Remember, we found f prime of 2.5 before. So notice in the problem it said excluding x equals 2.5. We already know that we had that slope there because that's why we found that slope. So these are the only two answers I need to include. That will be my final answer.